Welcome to the video. Today we're going to be solving a LeetCode problem, and I chose this one over here, 3306. That is count of substrings containing every vowel and k consonants number 2. That's a medium problem, and that's going to be working with arrays, and we're going to be using sliding window to solve this problem once again. So here it says we're given a string word and a non-negative integer k, and it's asking us to return the total number of substrings of word that contain every vowel, so A, E, I, O, U, at least once, and exactly k consonants. So that's a substring counting problem, where each substring, we need to count how many substrings are going to have at least once of every vowel and exactly k consonants. So for example, here in this example, we have k equals 1, so we need only one consonant in our string, in our substrings, and to get all of the vowels is impossible here because we need a U, right? So none of these substrings contain U, so the output is going to be 0. If you look over here, we have all of the vowels here, A, E, I, O, U, it's fine, and K is 0, so it's actually asking us to have 0 consonants, so we have one solution here, that's why the output is 1 here. And in this case here, we have K equals 1, so we want one consonant in our substrings, and to have each of the vowels in our substrings, we can have this option here. So that would count as 1. We also have this option over here. That will count as the second one. And finally, we have this one over here. That's the third one, right? So that's why we have here output equals to 3. Because we can form 3 substrings that have at least one vowel, one of each vowel, and one consonant each. All right, so to solve this problem, we're going to be using a sliding window technique where we have 2 pointers, one pointing to the left, one to the right, and we expand this window and contract it depending on certain conditions. So I have this presentation here open to make it easier to understand. So let's say we have this example here where we have this string and k equals 1. So we're asked to have one constant in our substrings. The way the algorithm is going to work is that we're going to get our window, our sliding window. We're going to step by step slowly increase it until we get a valid substring. So in this case here, we're going to be adding here all the way to this point. When we reach this point over here, we have now one of each vowel and we have one constant, right? That's what we asked for because k equals to 1 over here. So we know that at this point we have a valid substring. But this problem here is a bit trickier because the intuition will be, okay, we just got to add our answer. We got to increment our answer by 1 because we found a substring. But we can actually notice here that we can add more than just one substring. We can actually add this one here as well. And also this one here. And also this one here. Up until the next consonant. Because it doesn't matter how many vowels you have. As long as you have one of each, they're still valid substrings. So even though my window stops over here, I can still already add my answer by 4, right? Because I can add this one over here, I can add this one over here, I can add this one, and I can add this one over here, all the way up to the next constant. And so the tricky part here that we need to realize is that we need some sort of way of knowing what's the index of the next consonant at each element, right? So in this case here, we are at element 0, 1, 2, 3, 4, 5. That's index 5. We need to know that for index 5, the next constant is at index 6, 7, 8, 9, right? And if we know the next constant, we can add this index to our current index to get how much we need to add. So in this case, it would be 9 minus 5, which is 4, which exactly matches the 4 substrings we found. This one here, this one, and this one. All right, once we found a valid substring, we add, in this case, 4 to our answer. Now we need to start shrinking our substring until it becomes invalid. In this case here, let's go and shrink up to this one here. And now you see that it's not valid anymore because we don't have an I in our substring and we need one of each vowel. So at this point here, we can start expanding our window back from the right. So we're going to do the same thing here. We're going to add 1 to our right index, and now we have a valid substring again because we have one of each vowel and we still have one constant here, Q. And it's the same thing. We're going to be adding to our answer not just 1, but in this case here, 3. Why 3? Because that's how many substrings until the next consonant. Because we can add this one over here, we can add this one over here, and also this one over here. So 3. And how to find 3? Simply by getting the index of our right pointer and getting the index of the next consonant. In this case, it's still 9 over here, and our right pointer is at 6. So 9 minus 6, 3. So we add our answer by 3. And we follow this process throughout our entire string, and that should count the amount of substrings that obey the certain condition. All right, so now let's try to put everything that we talked about here in code. So let me go back now here to our LeetCode problem. And let's first get some useful variables here. So definitely n is going to be the length of our word. We're going to need a variable to store our answer, a left pointer, and let's set all that to 0. We're also going to need a set of the vowels so we can compare things easier. So let's call here vowels is going to be equal to a set A, B, A, E, I, O, U. That's our vowels. And now let's have a dictionary containing the vowels we find in our window. And we need a dictionary here because we need to know if we do have all of the vowels in our window, right? We need to actually know if we have A, E, I, O, and U for that to be a valid window. So let's call here MV, that's map vowel. That's going to be equal to a dictionary. I like to use the default dict because that already initializes values for you if it does not exist in the array, in the dictionary. And we can also have a variable for counting our consonants. And for that we don't need a dictionary because it doesn't really matter which consonants we're using. We just need to count how many we have in our window. So we can just do here consonants. Let's set that to 0, right? I could have put that up there, but that's fine for now. Now, the tricky part now is that we need a way to find what's the next consonant for each of our indexes in our array. So one way we can do this is to have a list, right? Call, let's say, consonant indexes. Let's call it next consonant indexes. That's going to be equal to, let's say it's an array of -1. And the size of this array is going to be the length of our word. We need one element for each letter in our word, so n, right? If our word has n letters in it, we're going to have here one space for each letter, and we're initializing everything to -1. So that's going to be -1, -1, -1, -1, all the way to the amount of letters you have in your word. So just initializing that. And let's also have here a variable called next consonant. That's going to be useful when building this array. That's going to set that to n. Let's call this next consonant index. You see why I'm going to be using this variable, but let's initialize that to the length of our word. Now we're going to be looping through our word in reverse order to build this list that is going to have the index of the next constant for each element. So to do that, we're going to do a for loop for I in range. And now here to loop from back all the way to the front of the array, we can always do n minus 1. That's the starting. That's going to be the last index, followed by when do we stop. And remember, we don't include the actual place that we stop, so we can put a -1 here, which means going to stop at 0. And -1, that's how much it's going to decrement at each iteration. So that's just a tricky way for you to loop over to iterate over a certain string or list in reverse order from back all the way to the front. And now we're going to try to populate now our next consonant indexes list. So we can do now next consonant indexes at position I. That's going to be starting at the last one. And let's set that equal to the next consonant index. That's the helper variable that I declared to make everything easier for us. And the first iteration is going to be the length of our array. Okay, Now we have we just populated the ith index of our next constant indexes. And now we need to see if our current element is a constant. We need to update our next constant index so that in the next time we iterate, it's going to be getting that specific index for the closest one. And so to do that, we can simply do here if words I in not in vowels, if it's a consonant, and vowels is our set, then we need to update our next consonant index. So next consonant index, that's going to be equal to I. We're going to be updating the next consonant index to the current position if it is a consonant, if it's not a vowel. And after this loop here, we might have then a full list of the next constant for every single position in our array. Okay, now we can actually start with our sliding window algorithm. We're going to be expanding and contracting our window. And as usual, we're going to have here a for using a right pointer. The left we initialize to 0 over here. So for right in range n. Now we're going to be updating our dictionary MV and our consonants. That's tracking the amount of consonants in our window. So the first thing we need to see is the current letter a vowel or a consonant? So if word right in vowels, so it's a vowel, then we need to update our dictionary MV with our current vowel and add 1 because we just found a vowel, so we need to put a vowel in our dictionary. If there's something already there, we're going to increment the amount of times we've seen that. Else, that's the case where it's a consonant, then we just got to increment our consonants variable here. Now, that's updating our window at every single point in time, every single iteration. And now we actually need to have the condition to contract our window. So we are expanding our window at every single point in time. So let's use a while loop over here. And that while loop is going to be responsible for contracting our window until it's no longer valid, right? We need to know if our window has 5 vowels. That's one of the conditions, right? So we can do here if the length of MV equals to 5. By length of the MV is going to take the keys. So even if we have 2 A's or 3 E's, it doesn't matter. It's just going to give us 5 because it takes the keys and not the values. So that's just going to tell us if we have our 5 unique vowels in our window. So if that's the case, and what is the other condition? The other condition is that our consonants, it's going to be greater or equal than k, right? Because if it's greater or equal than k, there's 2 possibilities over here. Either it's a valid string if it's equal to k exactly, or if it's not equal to k. So if it's greater than k, it means we cannot add anything to our answer, but we know we need to shrink that window. And that's why we put it here, a greater or equal than k. And now we need to check for a more specific case where consonants equals to exactly k. That's the case where we have our answer, right? And in this case here, we know that we have 5 vowels, and if it's also equals to k, we know we found a solution because that's the condition for our substring. And so we're going to be adding here our answer, not by 1, but by the difference between the index of the next consonant and the current index I'm at. And so we have our helper list over there, so we can get next consonant indexes at index right minus right, right? So at position right, this list here is going to tell us what's the position of the next consonant. This whole thing here is going to give us the position of the next consonant. And by subtracting the current position, we have how many substrings we can add to our answer. That's what I showed you in the PowerPoint presentation before. Now all we need to do is to contract our window until it's no longer valid, right? And so we're just going to move now the left pointer to the right. And so to do that, we first need to see if the letter on the left pointer, if word left, if it's a vowel, then we need to subtract it from our dictionary. So we're going to do MV word left minus equals to 1. So we're subtracting 1 from our vowel dictionary because we just moved the left pointer, so it's no longer in there. And we just need to check now here if that became 0. And if it did, then we just delete that entry from our dictionary. And that's important because otherwise its length of MV would always stay at 5 and wouldn't decrease even though the value is 0. That's why we need to delete the entry. The other case here is if it's a consonant, right? And if it's a consonant, all we gotta do is subtract 1 from our consonants variable counter, minus equals to 1. So that's shrinking our window, and of course here we do left plus or equals to 1 to actually decrease our window. But I think that should already be it. So let's see if we can return the answer over here. But yeah, let's try to submit this. Let's see if it works. We got a error over here. It says words not defined. Yeah, there's an extra S over here. Yeah, that's part where we gotta fix maybe some typos now. Let's see here in the run. Yeah, the run was accepted. Let's try to submit it again. And you see it was accepted here with 75%, beats 75%, and memory beats 11% over here. Yeah, but that's all pretty much all that I have for this video. Thank you for watching, and I see you next time.